Today we are going to study the basic programming for AVR microcontroller. So let us start our programming. So for this you just click on AVR Studio 4. Then this window is pop up. In this window click on New Project. And then select AVR GCC. Click on project name. So according to you, you just give the project name over here. For example, the given is HL. Then click on next. Then click on AVR simulator. Select in device window ATmega 32 advanced microcontroller. So it is ATmega 32. Then click on finish. When you click on finish, the window is appeared. You just observe your file name is created over the source in the folder source file, and that is hl.c. So you just write down your code in this window. So the code is written over here. In this code, the logical functions can be considered. So DDRA, DDRB, DDRC, all the ports are function as an output port, hence they can be initialized with FF value. Okay. In this way, your logical operations can be stored in port A, port B, port C. So then move to other edit configuration. Click on edit configuration. So this is your AVR toolchain. You have to select AVR GCC. For this, you have to follow the path by clicking over the three dots which are given in AVR GCC. Click on Win C, that is C drive, Win AVR 20100110. Then bin. From this bin, select AVR.gcc, this one. Click on open. Observe the AVR GCC.exe file is open. Similarly, click on Win7 for make file, Win AVR. Then utils. Click on bin. Then click on make. Okay. After that, click on open. So in this way, make.exe file is open. Finally, click on OK. Then once it opens, move to build. Okay. It is used to build your program which is written in AVRC. So click on build. When you click on build, the message is recorded, that is build successfully. So your program build successfully by clicking on build in this manner, by giving the message build succeed with 0 warnings. Warnings are 0. Then you have to debug your program. So click on debug. Start debug. Before starting the debugging, you just check your output device, that is IO view, port A, port B and port C. You just expand these ports. Initially you observe DDRA and DDRB, both the ports are 0, 0. Then start your debugging. Click on start debug. See the yellow arrow is there. Press F11 for debugging. So initially you again observe the DDRA, DDRB register, both are 0, 0. Initially before starting the debugging or pressing F11, when you press F11, okay, your LOR is on port A. Now see, after debugging, your DDRA, DDRB becomes 0, by FF. Okay, the result of X, that is my byte and my byte 2, the 2 bytes are defined there, my byte and my byte 2. Those ANDing operation can be stored in port A. Okay, see here the operation of port A. Okay, after debugging this, initially port is 0, but after debugging this you get the value 0 2, that is ANDing of 0 3 and 0 2, my byte 1 and my byte 2, that is 0 2, it is stored in port A. Similarly port Y and port C, you get the result of ORing in port B. Okay, that is my byte is my byte OR with my byte 2. Similarly you get the result of port C. At port C, that is complement of my byte 2, and you get the result in port C. See the result 0 by FD. Okay, so in this way the logical operation takes place by using AVR Studio 4. So after that we have to stop debugging by resetting it, and again you have to move to debug and stop debugging. Okay, in this way debugging of text, any AVR can be takes place. Now click on AVR Studio 4. Again for the second program we are going to see, choose AVR GCC. This is a second program. Write down the project name. Next, similarly you have to choose AVR simulator. Then Atmega 32 advanced microcontroller, you have to select from the list Atmega 32. After that you have to click on finish. Once you finish this, you just observe the source file which is created in the folder source file, that is n.c. Write down your code in editing window, that is seen AVR. Here you have the code for decimal to hex conversion. See here DDRA, DDRB are FF as an output code. Then bin byte is equal to 253. This is your decimal number. Okay, and the result is stored in port A, port B and port C. Whatever the result that is converted, 253 converted hex value stored in port A, port B and port C. Click on write other files, edit configuration option, then click on custom option. Again you have to go by using the path bin C, then bin AVR. By clicking it, you just click on bin. After clicking on bin, you have to search for avr.gcc. Once it find, you have to click it on avr.gcc, then open. So in this way you can open avr.gcc file. Similarly use the path for make WinAVR utils. From the utils you have to click on bin. Okay, from bin you have to find out make file. Okay, so this is your make file. Click on make, open it. In this way you open your both the file GCC and make, then click on OK. Okay, once you click, you have to build your program. So click on build program. When you click on it, the errors, if the errors are there, they can be recorded, but now it can be build succeeded with 0 warnings, no errors are there. After that you have to click on debug, start debugging. Okay, see here, when you start to debugging, you just expand the registers or ports, port A, port B and port C. Okay, initially you just check the port registers, they are 00, DDRA, DDRB, DDRC, all three are 00. When you start debugging, the FF value is stored in DDRA, DDRB in this way. When you press F11, FF are stored in the corresponding DDRA register, and the result of your 253 decimal number, that is hex value, is stored in port A, port B and port C when you press F11. See, initially port A, port B and port C all are 00. Okay, see, all these are 00. Okay, when you click F11, your result, that is D and FD, D stored in port A and F is stored in port B, is stored in your port A and port B. In this way 253 value can be converted to the hexadecimal value FD by using these codes. Okay, so this is your result which is stored in your IO registers. So in this way you can run your program. So let us stop now.